CCNA, Cisco. Certified Network Associate course. This is Jeremy's IT Lab. This course aims to be a complete course for the CCNA, including everything you need to pass the exam, all 100% free. Stay tuned till the end of the video for the quiz to test your knowledge of the material in this video. Also, remember to download and use the Anki flashcards with the link in the description. Let's get started. The second lesson is about interfaces and cables. In the last video, we talked about some different kinds of devices you will find in networks. This lesson will focus on how we connect them, specifically, how we connect them with cables. Wireless connections are also a topic we'll cover, but that's for later in the course. Take a look at this photo. This is the front of a switch. Notice the 24 interfaces, also known as ports. Remember, as we learned in the last lecture, one characteristic of switches is that they tend to have lots of interfaces to connect end hosts like PCs and servers to. Now let's look at those words above the interfaces. I'll zoom in. 10/100/1000 base T ports, 1 to 24. Ports are auto MDIX. Unless you've already studied this stuff, you probably have no idea what that means. Don't worry, by the end of this video, you'll understand all of this and more. Now let's focus on the interfaces themselves. I'll zoom in again. Do you recognize the shape? If your computer is connected to a wired network, it's surely using a port like this to connect to the network. These are called RJ45 ports. RJ stands for registered jack, by the way. Let's look at the RJ45 connector at the end of a cable. I'm sure you've seen one before. These are all cables with RJ45 connectors. As you can see, there are some variations in design and color, but all of these connectors would fit into the ports we saw in the previous slide. The RJ45 connector is used on the end of a copper Ethernet cable. There are Ethernet cables which do not use copper wiring as well, but we'll get to that later. First of all, though, what is Ethernet? Ethernet is a collection of network protocols and standards, rather than just a single protocol. So really, Ethernet isn't one single thing, making it difficult to define exactly what it is. For the purpose of this lesson, we will focus on types of cabling as defined by Ethernet standards. As said above, there are many standards included in Ethernet, but the focus of this lesson is interfaces and cables, so that's what we'll focus on. However, we will learn other aspects of Ethernet in future lessons. Now, before we learn about Ethernet cable standards, I want to give a brief explanation of why we need network protocols and standards. If two people are talking to each other, and one only speaks English, and the other only speaks Japanese, there's not going to be much or any communication between them. What they need is some agreed-upon system of communicating, like a common language between them. Network protocols serve that purpose for network devices. That's why standards like Ethernet exist.
That's why, like, so one time when I was like a kid, someone tried to tell me that my TV, I bought a TV on Black Friday and it wouldn't connect. And they were like, yeah, this TV was made in Japan, so like it only speaks Japanese, it doesn't speak English. I'm like, that doesn't sound right. Technology doesn't speak a language. Like, well, it does speak a language, but it's like technology speaks its own language. Like, so anyway.
Since we're talking about interfaces and cables in this video, here's a more relevant example. If you're trying to connect to, for example, a network switch, but the maker of the cable and the maker of the switch haven't agreed upon the size and shape of the connector and port, you won't be able to connect them. That's why...
So, last little story time. At work yesterday, I had a guy call in, and he was like, yeah, we have a guest speaker coming. I want to make sure that the projector works. But when we try to connect the laptop to the projector... No, he said, when we try to connect the laptop to the computer box, through USB, it doesn't talk to the projector. And I said, well, connecting a computer to another computer with a USB isn't how you connect those together. You should look for an HDMI port on the wall. And he was like, oh, man, I don't know where that's at. And I was like, well, go to a wall, find a outlet, and see if it's HDMI or not. And that'll tell you. He's like, man, I don't know where that stuff's at. And I was like, well, you could get a chair and just stand on top of it and look at the back of the projector. Okay. It was stupid. The guy was stupid.
There are industry standards that all vendors follow, both in terms of physical standards like connectors and cables, as well as logical standards like IP.
USB was a really big deal, too.
Now, connections between devices in a network operate at a set speed.
Firewire was way better.
These speeds are measured in bits per second.
But it was proprietary,
what is
so
a bit?
It lost.
Well, it's a value represented by either a 0 or a 1. This binary code is how computers work.
This
YouTube,
is important.
This video, your operating system, all of it is just a series of zeros and ones, which your computer interprets. When communicating across a copper network cable, a variation in the electrical signal is interpreted by the receiving device as a 0 or a 1. So that's a bit. What's a byte? Here we have a series of 8 bits.
And a nibble is 4.
8 bits is equal to 1 byte.
But I hardly ever hear anybody
speed is measured
say
in
nibble.
bits per second. Imagine a byte, 8 bits, of data being sent along a wire. It reaches the neighboring device 1 bit at a time like this. It doesn't operate 1 byte at a time like this. So remember, speed is measured in bits per second. For example, kilobits per second, megabits per second, gigabits per second, and not bytes per second. Data on a hard drive, for example, is measured in bytes, however. So remember, a gigabyte is actually 8 times larger than a gigabit. So let's review some of these measurements. 1 kilobit is equal to 1,000 bits. Add 3 zeros to that, and you get 1 megabit, which is 1 million bits. Add another 3 zeros, and you get 1 gigabit, or 1 billion bits.
Damn.
Add another 3 zeros to that, and you get 1 terabit, 1 trillion bits. You're not going to see larger units than this when it comes to network speed, and really you're not going to see terabits either. Speeds are always increasing, however, so terabits per second speeds may be commonplace soon enough.
How old is this? 6 years old?
Now, there are further units. Here's a snapshot from Wikipedia. Beyond terabits, there are petabits, exabits, zetabits, yodabits, and more.
Yeah, because
don't worry about memorizing all of these, though. You're not going to see network speeds like these anytime soon. Okay, finally, let's talk about some Ethernet standards. These are all defined in the IEEE 802.3 standard. The IEEE is the Institute of Electrical and Electronics Engineers. You'll notice all of these Ethernet standards begin with IEEE 802.3. Let's take a look. So, here's a table of some IEEE standards for copper Ethernet cables.
Yeah, it's all stuff that I
We'll also take a look at fiber optic cables later in this lesson, but I decided to split them up. We have one for each of the common network cable speeds: 10 megabits per second, 100 megabits per second, 1 gigabit per second, and 10 gigabits per second. Yeah. The next column lists the common names. These are the names we usually use when talking about different network interfaces, cables, and their speeds. For example, in a work environment. The next column lists the official IEEE standard in which they're defined. You would probably never use these names when talking with other network engineers about a cable, but you should be familiar with them.
I'm familiar with UBA.
This next column lists informal standard names given to each standard: 10 base T, 100 base T.
Because these letters right here represent whether or not it can travel across 2.5 or 2.4 gigahertz or 5G. Basically, like, you know, when on your phone, when like you have the 5G internet, that's like significantly faster than the 4 or the 2.4, right? But 2.4 can handle a whole bunch. And then there was a bunch of different variations where it was Wi-Fi was only 2.4, and then Wi-Fi was they tried only doing 5.0, and then they tried doing both, but they couldn't run at the same time. And then now they can run at the same time. It's very interesting. I have a video on Tyler Lemmond channel where I kind of break that stuff down a little bit more in depth than this.
1000 base T and 10G base T. The numbers obviously refer to their speeds, but how about base and T? Well, base refers to baseband signaling.
Twisted pair.
That's totally out of the scope of the CCNA, but just so you know the meaning. T refers to twisted pair cabling, and we'll talk about that very soon.
See, and that was another thing too. Here, go back to that. That was another thing too. Back in the day when everything was a Cat 5 cable, like when it was just a Cat 5 cable, everyone was like, "Oh yeah, you can get a gig. You can get a gig." Da 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 da. But this is the base. Refers to like what the lower denominator is, what's possible of that cable, and that wasn't possible all the time with a Cat 5 cable. It was possible some of the time under very certain some circumstances, like if it was a certain length or whatever, and that's how the phone companies like AT&T and stuff, whatever, they got around the base in telling people that it could run a whole gig, is that they only gave out wires that were that length. But even at that length, it was still kind of a hit or miss if you were going to get a full gig or not. And that was the maximum. So they kind of like did a little like marketing play to try to get that going to where it is. Unlike the 5E or the Cat 6 or the 6A.
Know the meaning. T refers to twisted pair cabling, and we'll talk about that very soon. Finally, the maximum cable length. Notice that all of them are 100 meters. That's the maximum length for twisted pair cables as defined in Ethernet for performance and technical reasons. So that's a lot of information, but I recommend you memorize these standards.
See, and that was
it may
the
seem
problem
difficult,
with
but with the flashcards in the description, it's actually quite easy.
5.
So don't forget to download and use the flashcards in the description, and also make your own if you want.
Marketing.
Okay, now let's continue and look in more detail at the physical cables themselves. The copper cables used in Ethernet standards are UTP cables.
Yep.
UTP stands for unshielded twisted pair. Unshielded means that the wires have no metallic shield,
like
which can make them vulnerable to electrical interference. The twisted pair part is easy to understand from this photo. As you can see, there are 4 pairs of cables twisted together. The twist actually helps protect against electromagnetic interference, or EMI.
This.
So there are 4 pairs of wires twisted together. That makes 8 wires in total. Let's take a look at one of those RJ45 connectors we saw earlier. If you count the number of pins here, you'll find that there are 8 pins, perfect for the number of wires we saw in the last photo. However, not all of the Ethernet standards we saw before actually use all 8 wires. 10 base T and 100 base T, also known as Ethernet and fast Ethernet cables,
this is the part that I
use
don't
2
know.
pairs, or 4 wires. 1000 base T and 10G base T, however, use all 4 pairs, or 8 wires. Let's focus on the first 2 for now, 10 base T and 100 base T. So let's say we're connecting a PC to a switch with a fast Ethernet connection. These numbers represent the pins on the RJ45 on the PC's network interface card and the switch's interface. There are 8, but we will only use 4, or 2 pairs, since this is a fast Ethernet or 100 base T connection. The first pair is at pin positions 1 and 2, and will connect to pins at positions 1 and 2 on the switch's network interface. Although in this diagram the wires look straight, remember that in a UTP cable, the pairs are twisted together. So in a real cable, these 2 wires would actually be twisted together like in the photo we saw.
Mm-hmm.
The PC will use pins 1 and 2 to transmit data to the switch, which we can write as TX. Because the PC is transmitting data on pins 1 and 2, the switch cannot transmit data on those pins. It has to receive data, which we can write as RX on pins 1 and 2. There's an important point to remember here. The network interface card on a PC, or server, transmits data on pins 1 and 2, and the interfaces on a switch receive data on pins 1 and 2. Now, the next pair that is used in a 10 base T or 100 base T cable is not 3 and 4. It's 3 and 6. And of course, the function of each pin is opposite of the pair on pins 1 and 2. On the switch, pins 3 and 6 are used to transmit data, and on the PC, pins 3 and 6 are used to receive data.
So this is the part that confuses me, is that on the PC, 4 and 5 receive data, but over here on the switch, it transmits the data. I think some of this stuff is so dumb. Like, why in the world would you ever, like, why would you need two ends of a cable? Like, why not have them be both? I know that it doesn't really matter now, but like, I don't know. Because they look the same. It'd be one thing if they look different, but it looks the same. Like, can you imagine if you plugged in your outlet into something that looked exactly like the plug? Like, it wouldn't, I don't know.
This allows for what's called full duplex transmission. Full duplex transmission means that both devices can send and receive data at the same time, and no problems like collisions will occur because they use separate wires to transmit and receive
data
data.
can collide on wires.
Just like that, both devices send data at the same time, and there are no problems.
Like a highway.
Let's change the device on the left from a PC to a router. Just as a PC usually connects to a switch usually connects to a router. Once again, it's a fast Ethernet or 100 base T connection.
Usually goes
so two pairs are used,
switch,
1 and
router.
2, and 3 and 6. Now, which pairs on which side are used to transmit, and which are used to receive? Well, we know how a switch functions from the last slide. Pins 1 and 2 receive data, and pins 3 and 6 transmit data. How about a router? Well, the network interfaces on a router transmit and receive data on the same pairs that a PC's network interface card does. A router transmits data on pins 1 and 2, and receives data on pins 3 and 6. Again, Ethernet uses full duplex transmission, so the two devices can send data at the same time with...
Okay, so they do this so that way, because each wire has to have its own information. You can't have information traveling on the same cable. Or not the same cable, but the same, like, copper strand. If you do, collision's going to happen, big wreck's going to happen. But if we look back at the computer one, where was it? The computer's transmitting and it's receiving on both cables. And then it does the opposite on 3 and 6. Don't worry about 4 and 5. That's not important. Not right now. Okay. And then...
You buddy.
Hey, what's up, dog? So we're receiving a computer and we're transmitting to the switch. And then for the router, we're receiving and we're transmitting. So is it, wait.
I need your suggestion.
What's up, dog?
issues. So remember this. Routers transmit data on pins 1 and 2, and receive data on pins 3 and 6. This is the same as a PC. Once again, switches are the opposite. They receive data on pins...
Yeah, I don't think, no, that's fine.
1 and 2, and transmit data on pins 3 and 6. When connecting a PC to a switch, or a router to a switch, this works fine. Because they transmit and receive on opposite pin pairs, a regular cable like this works well. This kind of cable, by the way, is called a straight-through cable. Remember, a copper Ethernet cable has two RJ45 connectors.
Approach towards learning cybersecurity and specifically ethical hacking.
So my biggest suggestion would be to, well, my question to you is like, how much do you know already? Like, are you going in completely blank? Do you know absolutely nothing? Or do you already kind of have some knowledge of like what's going on, like how to do basic like troubleshooting and things like that? If you know absolutely nothing, I would steer you to CompTIA. CompTIA's A+ is a really good starting position if you know absolutely nothing. That's where I started because
I know a bunch of stuff.
Okay, so if you know a bunch of stuff, then I would go toward CompTIA or CCNA. But I wouldn't start at the beginning. I would start somewhere around networking and or their cybersecurity. What's great about the CompTIA stuff is that it's very like user friendly, and it's very it fills in a lot of gaps. So if you're self-taught and you know a bunch of like things, but you've never formally learned anything, doing like the Network Plus or the Security Plus is a really good starting step to learn, like, do you know everything? Are there any holes that you need to be filled in terms of gaps of knowledge that you might have? And then the things that you'll learn there, you can project into the area where you need to go. my strong thing, because what I'm trying to do with the cybersecurity is I'm trying to learn networking, because in my mind, AI is a person and internet is the road. And the only way AI is going to be able to travel between things and be able to get to places is through the internet. So I feel like I need to know and understand basic internet connections and how those protocols work before I can move into like AI and how to defend against it and use it to attack, and to get me into cybersecurity. So I hope that helps a little bit.
Connectors, one on each end. This kind of a cable is called a straight-through cable because pin 1 on one end connects straight through to pin 1 on the other end. Pin 2 connects to pin 2, pin 3 connects to pin 3, etc. Now, in networks, we don't always connect PC to switch, switch to router. What if we want to connect a router to another router?
So this is straight through because data's transmitting it straight through. It's all going one direction on 2 pins, and it's all coming back on the other 2 pins. 1 and 2 is going directly to wherever it's trying to go to, and then 3 and 6 is taking it
to another switch, or maybe connect 2 PCs together. Now I've replaced the switch on the right with another router. What will happen if the router on the left sends data to the router on the right?
Okay, so now we're going to have issues because this is trying to transmit, but you have to remember that it's when dealing with trying to figure out like how data transfers, it's not just about the wire, it's also about the port too. The wire will transmit things a certain way based off of how it's wired, how it's like if it's going to be crossed or not.
Linux enough networking, and now I am thinking to STRT learning Linux Claylite tools, but I think I am rushing.
Well, the thing what I'll have to tell you about with rushing, if you can't explain what you know simplistically to somebody else who knows nothing or very little, then you're rushing. You don't actually know it. If you feel like you can explain that and actually explain that to someone who doesn't know a whole lot and they can kind of understand when you're explaining it, then you're probably fine. But learning Linux is a really good thing. Learning Linux is also really hard because up until like recently, Linux was kind of like you'd go into the threads and it'd be like, "What? You don't know this, loser?" It was kind of a pain. So, it sounds like you're in a really good position. I would push forward. Sounds like you know more than me, honestly, because I'm not good with Linux like at all. So I would push forward in starting to learn those things. And you can go to, what is it, .hackme or hackme.net or something like that. That's a really good website to see just how good you are in terms of like breaking in, attacking, defending, things of that nature. Yeah, that seems like a really good idea. I would go with that. Yeah, those are websites. I haven't heard of Hackathon or Hackerone, whatever, or Hacker One. I haven't heard of that one, but try Hackme. That's the one that I was thinking about.
Well, it's simply not going to work. The right router isn't prepared to receive data on pins 1 and 2 of its interface, so communication between the 2 routers just doesn't happen. So how can we successfully connect 2 routers together? Or perhaps 2 switches or 2 PCs? The same thing applies to connecting a PC directly to a router also, because they both transmit data on pins 1 and 2 and receive data on pins 3 and 6. Let's take a look. I've replaced the 2 routers with 2 switches, just to demonstrate that the same thing applies. If the switch on the left tries to transmit some data to the switch on the right, it doesn't work.
So then we're going to have to cross
The answer to this
these
problem
cables.
is a different type of cable. A straight-through cable connects pin 1 to pin 1, pin 2 to pin...
Because the cables go straight through. The crossover is when the cables are actually crossed.
Pin 2, pin 3 to pin 3, etc. But there's another type of cable, called a crossover cable. In a crossover cable, a pin on one end of the cable doesn't connect straight to the same pin on the other end. Essentially, the pairs are reversed on each end. So pin 1 on one side connects to pin 3 on the other side, and pin 2 on one side connects to pin 6 on the other side. As you can see, the 2 pairs, 1 and 2, and 3 and 6, are reversed. Then pair 3 on the left side will connect to pin 1 on the right side, and pin 6 on the left side will connect to pin 2 on the right side. The wires are crossed over each other, hence the name crossover cable. The transmit pins on one side are connected to the receive pins on the other side. So now the 2 devices can send data to each other with no problems.
Yeah, that could taking. I don't know if you guys can hear that or not. I have the TTS on, but he said taking computer science and then doing masters. So here's my thing when it comes to like getting degrees and stuff, whatever. Because I have a degree, not in cybersecurity or anything like that, but I have a degree. What I'll tell you is that the lie that was told to millennials is that you just need a bachelor's degree. That's like not true. That was true like for maybe Gen X and maybe Boomers, but that's not the case now. You need three things. You need experience, you need a certification, and you need a degree. Any one of those three things can land you a job, but if you have all three of those things, then the chances of you getting a good job and a really high paying job, like a good one, is significantly higher because people who only have experience have like a chip on their shoulder. They feel like they don't need the certification and they damn well don't feel like they need to go back to school. People who have certifications try to get experience and it kind of helps them out a little bit, but they feel like they don't need the degree. And people who have the degree feel like they don't need experience and they feel like they don't need the certification because why do I need the certification if I have the degree? When in reality,
Skills and knowledge is everything a person needs to ace a field.
yes, but it's the credentials on the end that can help you get through. Because what I think what a lot of people forget about is that when you apply for a job, and I think this is one of the reasons why a lot of people are having a hard time finding jobs, is that you have a resume that has certain keywords, that has certain things in there that gets you through the filtration system. So you might have the knowledge and you might have the skills to ace whatever field, but if you can't get through the filtration system in order to even get an audience with the person to hire you or to even get hired, then it doesn't matter how many skills you have, it doesn't matter how much knowledge you have, right? Because it's all robots that are going through the resumes. So my recommendation is to do your best to acquire all three of those things. Because when you're going for a job and you're trying to excel in an industry, you need something that's going to set you apart. And what's going to set you apart is doing something that others aren't willing to do. And people who have the degree don't think that they need the experience and don't think that they need the certification, although some do. So if you're able to acquire all three, now you're an outlier. If you're able to have the experience, the certification, and the degree, you're now an outlier. And then it just becomes a matter of having an ATS resume so that way it can get scanned through the filtration system, and then an in-person resume so that way it looks good for people to read it. And this goes beyond AI. There was already filtration systems that were ran by bots and automation and stuff like that before like AI became big and stuff like that. But you are correct. So that is what I would tell you to do. That's what my thoughts are on that stuff. Anyway, let's get back to the video.
Here's another example. Again, the network interface card on a PC and the network interfaces on a router both transmit data on pins 1 and 2 and receive data on pins 3 and 6.
So that tells me, so the idea is that it's always a computer, a switch, and a router. And the switch is the middleman. Computers aren't necessarily always plugged into routers. I know we use the word router more as like a global term nowadays, like oh, that's my router. It does Wi-Fi and it does my switching. Like it's like an all-in-one kind of thing. But routers are kind of different.
Mentor for cybersecurity, like I know the approach, but I just don't want to waste time on SMT, which isn't required. So I left. I could approach you, and I appreciate it, buddy.
Well, I appreciate that a whole bunch, and I'll try to help you. I understand the importance of having a mentor is absolutely critical. Absolutely critical. I don't know what SMT is. I might be dumb. I hate acronyms. Whatever. But it sounds to me like you should maybe don't need the whole. Sounds to me like what I did because I needed a mentor too. And I needed direction. So I took a semester at a junior college, and that's when I took like the CCNA 1, 2, and 3. I took some coding classes. I took some things. Now I was a total beginner, by the way, so like this was greatly helpful. But being able to talk to those professors who were not just professors, they weren't just people who were like, "Oh, I'm teaching the class." Like they were actually people who were in the industry who were teaching this class, and they really kind of guided me to where I needed to go. So if you're looking for a mentor, I would suggest going. Don't go to a university. It's going to be way too much damn money. Just go to a community college, a junior college. Find a like the computer science department. Find the career education department. If you go there, you're going to find people who are actually in the industry. They're probably currently still in the industry and looking for a little bit of extra side income. So they decided to teach like a class at the local college. If you go there, take a semester, it'll probably only cost you about $1,000, maybe $2,000, which I understand is still quite a lot of money for a lot of people, but it beats the $10,000, $15,000 of taking one semester over at our 4-year university. And then you can build a relationship with them. They can be a really strong mentor, and then they can help guide you in a direction. Because it sounds like to me you're really just looking for a resource and a direction. And that's what teachers are supposed to do. You know what I'm saying? I hope that helps. I hope that helps a whole lot. Also, I know that sounds super cringe. I would consult an LLM. I would go to ChatGPT. I would go to Claude, go to Gemini, and I would just be like, this is the knowledge that I know. These are the certifications I have. This is the experience that I have. This is my goals and what I want to do. What is the direction that I should go in? And of course, take it with a grain of salt. You know, you don't want to live and die by the AI, but a lot of the AIs now cite themselves. So they'll give you something like I know Gemini and ChatGPT and Claude all cite themselves when they give you an answer when you're asking questions like this. So then you can just kind of go down like this little rabbit hole kind of thing, like how we used to with Google. You know, you would ask Google a question, it would give you all these articles, you'd kind of go down this rabbit hole. You wouldn't believe every single article, you would just kind of move on. You know what I'm saying?
Into cybersecurity, right?
I am into cybersecurity, but right now where I'm at with learning is the basics of networking. I haven't gotten into the cybersecurity areas of like penetrating and things like that. Mainly because I was other personal things. I was like a teacher, and now I'm not a teacher. Now I'm fully in IT, and so I've been handling my career transition. That's been a bit of a deal. Time taker is what it's been. So anyway, that's what's been going on with that. So the next step after I take my CCNA and I get that is I'm going to start diving more into the Security Plus, the like AI and how that works in terms of
Could you
security.
be my mentor, like he'll approach you on YT Live or something whenever I feel stuck?
Sure, absolutely. You can always drop it into the comments. You can always come in here right here. I'll do my best. I'm not going to tell you that I'm the absolute best person in the world that knows who's this stuff, but I mean, I'll always try to help you and steer you into the right direction, man. Yeah, for sure.
However, if you connect them together with a crossover cable, they will be able to exchange data with no issues. Here's a chart
Now,
reviewing
if I
different
can't
device
figure out
types
the answer, I'll
and the
try
pins
to
they
help
use
you
to transmit and receive data.
find the answer.
Routers transmit data on pins 1 and 2 and receive data on pins 3 and 6. Firewalls are the same as routers. They transmit data on pins 1 and 2 and receive data on pins 3 and 6.
Thanks, buddy. I appreciate
PCs also transmit data
No
on
worries,
pins 1 and 2 and receive data on pins
Glad
3
to
and
help.
6. Switches are the only different one of the group. Switches transmit data on pins 3 and 6.
Okay, so this is
and
what I was
receive
saying a
data.
second ago. It's kind of like switches are the middleman. So to me, this makes sense that it would be computer, switch, router. So the computer and the switch are able to talk through a straight through cable, and the switch and the router are able to talk to a straight through cable. But if you do the router and the computer, they need a crossover cable. That makes sense to me. The firewall also makes sense to me too because it's usually in between things. Okay. So that means if the computer was talking to the switch, it needs a straight through cable. You know, straight through because you can see that this is how it works. Data's going in and out on the same cables. Okay. And then that means that the PC to the firewall is going to need a crossover. The PC to the router is going to need a crossover. The firewall to the router is going to need a crossover. This is really good. I've always struggled with understanding the difference between straight through and crossover. Man, Jeremy, Jeremy, not Jeremy. No, I don't want to be rude. Jeremy really explains this really, really well.
On pins 1 and 2. Try to remember these. The flashcards included in the description will help with this, so I recommend that you use them. While all of that is important information to know, and can cause issues in networks even in the modern day.
Oh, so then the switch and the switch would also need a crossover.
That most modern networking devices have evolved beyond having to worry about straight-through or crossover
true.
cables.
We're kind of beyond this.
That's because newer networking devices include a feature called Auto MDIX. Previously, if two switches were connected with a straight-through cable like this, they would be unable to communicate. However, Auto MDIX allows devices to automatically detect which pins their neighbor is transmitting data on, and then adjust which pins they use to transmit and receive data. They can then exchange data normally. So, unless you're working with network equipment that is quite old, you don't really have to worry about straight-through and crossover cables. But this is good information to be aware of, and it's also good to learn about the concept.
Okay, so my thing is with this, is I'm glad that we have this Auto MDIX, like, protocol, whatever, that just kind of adjusts on the fly. But why was it different to begin with? Why wasn't the port standardized on all platforms? On the PC, the switch, the router, the firewall? Why wasn't that the same across the board? So that way it just worked no matter what direction I plugged in the cable. That's what I don't understand. Like, why? Where was it? Why is the router the outlier? Or why is the switch the outlier? Like, why are they not all the same? And then, because if they were all the same, then every single device would just need a crossover cable and everything would have been fine. But it's because switches were different, we needed something different. See, that's what I don't understand. I don't know. Maybe it's worth a Google.
Detect which pins their neighbor is transmitting data on, and then adjust which pins they use to transmit and receive data. They can then exchange data normally. So, unless you're working with network equipment that is quite old, you don't really have to worry about straight-through and crossover cables. But this is good information to be aware of, and it's also good to learn about the concept of Auto MDIX, both for the exam and for real-world networking. So, we've talked a lot about 10 base T and 100 base T, but what about the higher speed copper Ethernet cables? Remember, I said before that for gigabit Ethernet and 10 gigabit Ethernet, all 8 wires are used. The last 2 pairs are 4 and 5, and 7 and 8. Again, there will be flashcards to help you remember these details. It may seem like a lot to memorize, but if you use the flashcards properly, it's amazing how easy it is to remember all of these things. Now, here's another big difference between 1000 base T and 10G base T, and 10 base T and 100 base T. In addition to using all 4 pairs of wires, in 1000 base T and 10G base T, each pair is bidirectional, meaning each pair isn't dedicated specifically to transmitting data or receiving data. This is part of the reason that they can operate at much faster speeds.
Oh, wow. I didn't know that.
We've covered a lot about connections using copper UTP cables. But there is a newer technology that is superior in many ways. For example, copper UTP wiring can be used for up to 100 meters. That's usually plenty within a LAN, but how about for larger networks? Look at this Cisco switch here.
SPF?
Here it has 24 ports for RJ45 connectors. These are the ports you would connect a copper UTP cable to. But what about these 4 interfaces? Take a look at this Cisco router also. It only has 4 RJ45 ports. The rest of them look like those other 4 ports on the switch.
Mm-hmm.
In these interfaces, you insert one of these. It's called an SFP transceiver.
SFP, that's it.
SFP means small form factor pluggable. So you insert one of these into the device, but still things aren't complete. What kind of cable connects one of these?
Those things cannot get dirty, by the way.
You connect one of these cables. This is a fiber optic
cable. You get dirt
cable.
in there, you're done.
Rather than an electrical signal over copper wiring, these cables send light over glass fibers. Notice that there are 2 connectors on each end. That's because you need one connector to transmit data and one to receive data on each end. The copper UTP cables use separate wires within the cable to transmit and receive data. The fiber optic cables instead use separate cables to transmit and receive like this.
Yep.
Of course, transmit on the left connects to receive on the right, and transmit on the right connects to receive on the left. Now let's examine the structure of the cable itself. There are 4 numbered parts in this diagram, from the center to the outer layer. Number 1 is the fiberglass core itself. Light is transmitted down this core to transmit data from one device to another. Number 2 is cladding that reflects light. Number 3 is a protective buffer, which protects the fiberglass from breaking. And number 4 is the outer jacket of the cable. Now, there are a couple main types of fiber optic cables: single mode fiber and multi-mode fiber.
That I want to do too.
Let's check out their characteristics and differences. These are 2 examples of multi-mode fiber cables. The center represents the fiberglass core, and the blue represents the reflective cladding that reflects light down the cable.
This is how there was a guy that made internet like 10 times faster because he realized that there was all this space that we weren't utilizing. I don't remember all of it. It was a long time ago when I read the article. I knew less then than I do now. So anyway.
In multi-mode fiber cables, the core, the actual glass fiber, is wider than single-mode fiber. This wider core allows multiple angles, known as modes, of light waves to enter the fiberglass core, as you can see in these 2 diagrams. Notice the red and black lines representing light waves traveling down the fiberglass core, reflecting off the cladding at different angles. Multi-mode fiber allows longer cables than UTP, which are limited to 100 meters, but still shorter than single-mode fiber, which we will look at next. Multi-mode fiber cables are cheaper than single-mode fiber, and this is because they use cheaper transmitters, which are often LED-based. This is an example of a single-mode fiber cable.
Fiber's expensive.
Again, the center represents the fiberglass core, and the blue represents the reflective cladding. The core diameter of a single-mode fiber cable is narrower than a multi-mode fiber, meaning the glass fiber is thinner. You can notice this in the diagram here, compared to the multi-mode fiber diagrams. Light enters at a single angle, known as a mode, from a laser-based transmitter. Notice in the diagram that the light wave travels straight down the core of the cable. Single-mode fiber allows longer cable lengths than both UTP and multi-mode fiber cables.
Yep.
And single-mode fiber cables are more expensive than multi-mode fiber cables, due to the more expensive laser-based transmitters used. Okay, now let's look at some standards for fiber optic cables like we did with UTP cables. Here's another chart like the one we looked at for copper UTP cable standards, this time for fiber optic cables. First up is a standard for 1 gigabit Ethernet over fiber, known as 1000 base LX. It is defined in the 802.3Z, or Z, standard. This standard can be used over single-mode or multi-mode fiber cables, and you can see the difference in the maximum cable lengths: 550 meters for multi-mode fiber, and 5 kilometers, or 5,000 meters, for single-mode fiber. Next up is 10G base SR.
So just real quick, just so that way you can kind of see how this stuff is. Like, these are the fiber cables that are on the floor of the ocean. Like, is this not insane? Look how huge these things are. That's so crazy. And then they finally picked one up. I don't remember what it was. And then this is like how the internet is connected to everything. That's so wild. I don't know what the picture that is. That just looks crazy. What lies beneath a growing thread of the hidden network of cables that power the internet? The hidden thread. Interesting. Anyway, I just thought that's crazy because like they're so big. There was a picture or a video of it. I can't find it. I thought maybe I'd be able to find it. Is this it? Okay, it's not worth. That's AI. Okay, I appreciate the visuals, but like I want to see something real. Anyway.
Defined in the 802.3 AE standard, which operates at 10 gigabits per second. It uses multimode fiber and can support cable lengths up to 400 meters. Next is 10G base LR, also defined in the 802.3 AE standard, again operating at 10 gigabits per second. 10G base LR, however, uses single mode fiber, and cable lengths can be up to 10 kilometers. Finally, 10G base ER, also part of the 802.3 AE standard, and operating at 10 gigabits per second. It supports cable lengths even longer than 10G base LR, with distances up to 30 kilometers possible over a standard connection.
That's crazy.
This is just a sample of fiber optic standards. There are plenty more. I will include flashcards to help you remember these standards, but to be honest, I doubt you'll be asked questions about specific details about the standards on the exam, but I don't know for sure. However, with the flashcards, it's quite easy to remember these little facts, so I recommend not deleting those flashcards, but that's your choice, of course. Finally, let's review by comparing UTP cabling and fiber optic cabling, starting with UTP.
It stands for
Copper UTP cables are cheaper than fiber optic cables. Maximum cable distances for UTP cables are shorter, about 100 meters maximum. UTP cables can be vulnerable to electromagnetic interference, or EMI, although the twist in the cable pairs helps protect against this. The RJ45 ports to which UTP cables connect are cheaper than the SFPs used for fiber optic connections. Also, UTP cables emit or leak a faint signal outside of the cable, which could possibly be detected and used to copy data, posing a possible security risk. Now, let's look at fiber optic cables. Fiber optic cables are more expensive than UTP cables. They support longer distances than UTP cables. Their SFP ports are more expensive than RJ45 ports, and single-mode fiber ports
They're
are more
not
expensive than
vulnerable to
multi-mode.
EMI either.
They do not emit any signal outside of the cable, so there's
Yep.
no security risk there. Okay, so we covered a lot of information, but I want to remind you of the supplementary materials for the video that will help you remember what you learned. Like in the last video, there will be an end-of-video
Yep.
quiz
And
starting
that's
from
what
the
we're
next
about to
slide.
do.
Also, I have made a deck of flashcards to help you review the information covered in this video. Check the link in the description to download them. And there will also be a practice lab using Packet Tracer, which will be released as a separate video. Okay, let's get started with the quiz. Quiz question 1.
All right, here we go.
You connect two old routers together with a UTP cable. However, data is not successfully sent and received between them. What could be the problem? A. They are connected with a straight-through cable.
Yes.
B. They are connected with a crossover cable.
Nope.
Or C. They are operating in auto MDIX mode.
Nope.
Pause the video to think about your answer.
So he said auto MDIX. That's like newer, but he said it was older. Crossover. It's gonna need a crossover because they're the same device. Since they're the same device, they can't have a straight through. Straight through has to deal with the wires that are the coppering cables and how it transmit data, and the port that it's going into.
The answer is A. They are connected with a straight-through cable.
God, I was wrong.
Let's check each of the possible answers. A crossover cable is not the issue. In fact, a crossover cable would likely fix the issue. Because both routers transmit data
Okay,
on
I
pin.
wasn't wrong. I answered the question wrong. All of my reasoning was correct. The question was asking what was wrong, not what the solution was.
1 and 2, a
Gotta
crossover
read
cable
the
is necessary
question,
to properly
man.
connect the transmit
Gotta
pins
read
on
it.
one side to the receive pins, 3 and 6, on the other side. Modern devices with auto MDIX enabled don't have this issue, but it is possible that the old routers do not have auto MDIX. So B, they are connected with a crossover cable, is incorrect. Auto MDIX allows devices to detect which pins and wires their neighbors are using to transmit and receive data and adjust their own operations to match. Actually, auto MDIX would likely fix this issue, but since the routers are old, they might not have the auto MDIX function. So C, they are operating in auto MDIX mode, is incorrect. On old devices without auto MDIX, a straight-through cable cannot be used to connect devices of the same type. A crossover cable is necessary. So A, they are connected with a straight-through cable, is the best answer. Quiz question 2. Your company wants to connect switches in two separate buildings that are about 150 meters apart. They want to keep costs down if possible. What kind of cable should they use? A,
They wanna
UTP. B, single-mode fiber. Or C, multi-mode fiber.
No,
Pause
people
the
are
video
going to
to
say
think about your answer.
multi-mode fiber because of the 150 meters, but 150
The
meters.
answer is C, multi-mode fiber. Let's check.
Oh, it's because it's 150 meters, and UTP only goes to 100 meters. So the normal copper cable is not going to cut it. I mean, coax would probably do it, but we're not talking about that.
Although UTP would keep the costs down, it does not support distances over 100 meters. So A, UTP, is incorrect. Although single-mode fiber supports distances much
Expect
longer than
anything
150
less.
meters, it is more expensive than multi-mode fiber. So B, single-mode fiber, is not the best answer. Multi-mode fiber supports distances over 150 meters and is less expensive than single-mode fiber. So C, multi-mode fiber, is the best answer. Let's go on to question 3. Your company wants to connect two offices that are about 3 kilometers apart. They want to keep costs down if possible. Which kind of cable should they use? A, UTP.
No, 3
B,
kilometers.
single-mode fiber. Or C, multi-mode fiber. Pause the video to think about your answer.
3 kilometers, either multimode or
The answer is
single mode.
B, single-mode fiber.
Yeah.
Let's check the answers. Although UTP keeps costs down, it does not support distances of 3 kilometers. So A, UTP, is incorrect. Although multi-mode fiber is cheaper than single-mode fiber, it also does not support distances of 3 kilometers. So C, multi-mode fiber, is incorrect. Many single-mode fiber standards support cable lengths much longer than 3 kilometers. Although single-mode fiber is more expensive than the other options, it is necessary in this case. So B, multi-mode fiber, is the best answer. A switch has the following indication over its network interfaces. What would happen if you connected to an identical switch with a straight-through cable? A, they would operate normally. B, they would operate at a reduced speed.
No, they
Or
wouldn't
C,
operate at all.
they would be unable to
They
communicate.
would be unable to
Pause the video to think about your answer.
Because there are 2 switches, right?
The answer is A, they would operate normally.
What?
Let's check.
What? What? Okay, read the damn question again, Tyler. Okay, a switch has the following indications over its network interface. Oh, damn it. Read the fucking question. Read the question. So the ports are auto MDIX, meaning that it doesn't matter what you use. So it would operate normally.
They would not operate at a reduced speed. The ports are auto MDIX enabled.
I got.
However, even if they didn't have auto MDIX, they wouldn't operate at a reduced speed. They simply wouldn't operate. So B, they would operate at a reduced speed, is incorrect. Because the ports are auto MDIX enabled, they would be able to communicate, even though they are connected with a straight-through cable. So C, they would be unable to communicate, is incorrect. Because the ports are auto MDIX enabled, they would operate normally, regardless of whether they are connected with a straight-through cable or a crossover cable. So A, they would operate normally, is the correct answer. Let's go to the final quiz question for this video.
Alright, let's do it.
Your company needs to connect many end hosts to a switch which is in a wiring cabinet on the same office floor as the hosts. What kind of cable should they use? A, UTP. B, single mode fiber. Or C, multi-mode fiber.
Oh, just UTP.
Pause the video to think about your answer.
No, you're not going to connect. You're not going to use fiber to
The answer
connect
is A,
computers
UTP.
to switches.
Let's check the answers. Most hosts do not have the capability to connect to a switch via fiber cabling, and most switches do not have enough SFP interfaces to support many hosts. So B, single mode fiber, and C, multi-mode fiber, are incorrect. UTP cables are the standard for wired connections to switches. Switches typically have many RJ45 ports for end hosts to connect to, and end hosts will have an RJ45 port on their network interface card to connect a UTP cable to. So A, UTP, is the correct answer. Thank you for watching.
Sweet. So definitely subscribe to Jeremy's IT Lab. And while we're talking about subscribing, go to my tech channel. If you are here with Paradiddle Pete, go to Tyler Lemmond. That's where a lot of my tech stuff is at. So you should go check it out and listen to it, or and see some of my videos that are there. We are about to get into the flashcards, and then we're going to do the packet tracer. So the flashcards. Boom! Flashcards. Which, no matter how big I make this, it still is small. Okay, here we go. Study now. What is the speed of an Ethernet connection? The speed of an Ethernet connection. Well, it can be a lot of things. Like, there's a lot of different Ethernet connections. I don't like that one. Because there's a bunch of Ethernet connections. Because Ethernet can go up to like a gig. Actually, Ethernet can go up to 10 gigs now. Okay. We'll say it's fine. Okay, 10 G base LR maximum cable length. Is that okay, that's fiber. The LR is fiber. I think it's 5 kilometers. 10 kilometers. Okay, in the fast Ethernet connection, a router and I understand now. I understand. So we have Ethernet, fast Ethernet, things like that. Okay. Okay, I didn't realize. I understand the assignment now. Okay, in a fast Ethernet connection, a router receives data on which pins? It should receive it on 1 and 2, right? 3 and 6. God, dude, I'm not doing well. Fast Ethernet connection. A firewall receives data on 3 and 6. Yes. Because the only ones that's different is the switch. How many pairs of wires are used in a 10 base T cable? 4. Yeah. Okay, the IEEE standards, 100 megabytes Ethernet, 100 base T. Is it want me to know the standard? Like 802 dot, it's 802.11. No, that's Wi-Fi. 802I? U. So 802.11 is Wi-Fi. 802.3 is Ethernet. I used to know the lore about why it's 802. I don't remember it anymore. 10 G base LR maximum cable length. That was 10 kilometers. Yes. In fast Ethernet connection, the router receives data on pairs. The router receives it. That's the big thing, which is 3 and 6. The only one that's different is the switch. Okay, IEEE standards, 10 megabyte. Was it U? No, it's I. Those are going to be hard for me to remember. 10 megabytes is I. What is the speed of a 10 gig Ethernet connection? What does it mean by speed? Oh, okay. That makes sense. Okay, next. I don't know if we're going to go through all of them. There's like 56 or 57, something like that. So we'll go through as many as we can. Anyway, Ethernet was originally defined as IEEE standard in 18. IEEE 802.3. Yep. Some of these are just facts that don't really matter. I mean, it's important for you to know for the industry, but like, I'm not thinking that when I'm connecting cables. It just kind of is. It is what it is, you know. You know, like it's kind of like drums. Like you don't need to memorize all the brands and the differences between them. You just kind of figure it out and memorize it because like that's what you do, you know. IEEE standard blank equals 100 megabytes Ethernet. 100 megabytes. Is that AU? It's just U. Dang it. Those are. Yeah. Those are gonna be tough. Oh dang! I didn't even read the stupid question. Okay. Well, we'll just have it circle back around. What is the speed of 10 gigabyte Ethernet? 10 gigabytes a second. Yeah, those are easy. What are the two main kinds of fiber optic cables? Multi-mode and single mode. In a fast Ethernet connection, a PC receives data on which pins? 1 and 2, right? 3 and 3 and I knew that because the switch is the only one that's different. Okay. Which is cheaper, single mode or multi-mode? Multi-mode. We'll do 5 more of these and then we'll get to the packet tracer. The IEEE standard equals 10 gigabytes Ethernet. Is I. 10 gigabytes, not 10 megabytes. Man, you got to read these questions. You can't go too fast. And how many pairs of wires are used in a 10 gigabyte? Oh, all 8. All 8. Yeah. Fiber optic cables are connected to blank transceivers in a router. I always want to call it FPS, but it's not FPS. SFP, that's what it is. Small form factor pluggable. Cables emit a faint digital signal outside the cable, which can be detected and copied. Oh, Ethernet cables. I thought it was just saying true or false. UDP, unprotected cables. This, by the way, is a protected cable because it has the it has this, which I should have cut off, but I didn't. All right, here we go. If auto MDIX is disabled, what kind of UTP cable should be used to connect two routers? A crossover. Yes. Good. This will be the last one, and then we'll do the packet tracer. IEEE standard blank equals 1 gigabyte Ethernet. AN. AB. I wonder if the AB, AN, the I's, I wonder if that connects with the wireless protocol, the IEEE 802.11. I wonder if they're the same. I bet you they are. All right, last one. Why are the wire pairs in UTP cables twisted together? To protect from interference. Yep, to protect from EMI, electromagnetic interference. Okay, we will come back. We'll come back to this. Newing. Annoying. Okay, over here. We shouldn't need that. Not right now. No, that's right. That's the correct one. Now, I think these are packet tracers that he created. I don't think they're packet tracers that are done by Cisco, which we will also do. We will do this, the Cisco packet tracers as well. Anyway. Here we go.
Welcome to Jeremy's IT Lab.
After
This is a
we'll get back to
free,
the
complete
flashcards.
course for the CCNA 200-301. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment and share the video to help spread this free series of videos.
Yep.
Thanks for
Go
your help.
like,
Let's get started.
subscribe. Jeremy's IT Lab.
In this lab,
is
you'll
great.
use what you learned in Day 2's lecture video to connect these network devices together. You can select various types of connections from the bottom left here. We'll be using copper straight through, copper crossover, and fiber connections. Note that Packet Tracer doesn't differentiate between single mode and multi-mode fiber, but try to think about which type would be appropriate when you use a fiber connection. So, I'll start here in the bottom left. First, the connection
Okay, so what we're doing is we're connecting network devices together according to the labels. Use the appropriate type of cable. For practice, assume that auto MDIX is disabled and not supported on the devices. Note, Packet Tracer does not do these things. Okay, cool. So what we're going to do is we're going to look at each individual one and we're going to see which type of cable that we need. So if we remember correctly, everything that we do, the switch is the only one that's different. So that means that anything going to a switch is going to need a straight through. Everything else is going to need a crossover. That's the biggest thing that I think that I can, you know what? And we'll check that. Let's check it. Is a good rule of thumb that when connecting devices that only a device going to a switch needs a straight through cable, and any other combination including switch to switch. That is not how you spell including. I don't know what I was thinking. Okay, let's fix some of this. Okay. Including switch to switch needs a crossover cable. Is close but not exact. The older CCNA rule, crossover cable connects different types of devices. Oh, sorry, straight through. Cross cable connects same type devices. But so PC to switch, router to switch, switch to switch. No, so I'm right. This rule of thumb is stupid. That doesn't help. So straight through cables connect different types of devices. Well, that's wrong. These are different types of devices, the PC and the router, and it uses a crossover. Basically, the formula is this. X device that goes to switch always uses a straight through cable. Any other combination, including switch to switch, all uses crossover. That's a so much easier rule of thumb. Okay. This is dumb. So I am correct. You only need a straight through cable when connecting to a switch, unless it is switch to switch. Yes. Example, in that table, your rule works. Yeah, but MDIX makes it. Okay. So I was correct. It didn't matter, but it mattered. So that means that from PC to switch needs to be a crossover, or it needs to be straight through. Switch to switch needs to be crossover, and then switch to router needs to be a straight through, and then router to router needs to be a crossover. This should be super simple.
Between
Let's check
switch
it.
3 and PC 1. For the purpose of this lab, we're assuming that auto MDIX is disabled or not supported on the devices, so we have to think about whether to use a straight-through or a crossover copper cable. PCs transmit data on pins 1 and 2 and receive data on pins 3 and 6. Switches are the opposite. They transmit data on pins 3 and 6 and receive data on pins 1 and 2. So, we can use a straight-through cable to connect all of these PCs, as well as server 1, to the switches. Select straight-through cable here and connect the PCs to their appropriate switch. PC 1 to switch 3. Connect the Fast Ethernet 0 interface on the PC, which is the PC's network interface card, to any of the Fast Ethernet interfaces on the switch. Next is PC 2 to switch 4, PC 3 to switch 7.
Hold on, there's a button I can press. And then it should now just do it. Ugh, maybe it's control. Is it control? Straight through. Yeah, it was control. If you hold control, then you don't have to go back and always hit it. Okay.
And server 1 to switch 8. Now, we've got a bunch of switches to connect together. Devices of the same type require crossover cables, or else the transmit pins will be connected to the transmit pins, and the receive...
Man, that's so dumb. Like, why was that the rule of thumb? Because that rule of thumb doesn't work, because if you're going to connect a computer to a router, which I guess you don't really do very often, but if you're going to do that, then it's got to be a crossover. It's much easier to think of it in terms of that switch is the only outlier. So anything going to a switch is going to be a straight through.
Receive pins will be connected to the receive pins, which will not allow data to be sent successfully between the devices.
Look, and it's
so
all
let's
working.
connect these switches. Switch 3 to switch 1. Switch 1 to switch 2.
Okay, I'm going to finish this out. So here's the crossover. Wait, didn't I already do this one? No, I didn't. And then that means that, so cancel, straight through from here to here, from here to here, from here to here, from here to here, and then here to here, here to here. Oh, it's too big of a difference. I don't think I can connect those. Because 3 kilometers, that's big. That needs fiber. So it's going to need, I think single fiber will do it. Auxiliary. Okay, we're gonna watch it up to that point.
Switch 4 to switch 2.
Ah, crap! I forgot to connect those.
Switch 7 to switch 5. Switch 5 to switch 6.
What kind of mesh are we doing?
And last, switch 8 to switch 6. Next, let's connect these switches to the routers. Routers are like PCs. They transmit on pins 1 and 2 and receive on pins 3 and 6. So let's connect them to the switches with straight-through cables. Switch 1 to R2. Switch 2 to R2.
Yeah,
Switch
I just
5
think of
to
it as a
R4.
mathematical formula.
switch
Device
6
equals
to R4.
X plus switch equals.
Now it's time to connect the routers. Since they are the same
straight
device
through.
type, we need to use crossover cables if we use copper cabling.
Same
Take
device
care to look at the distances here.
plus
Since R1 and
any
R2
other
are
device
just 50 meters
other
apart,
than a switch
we can use copper
equals
cabling,
crossover.
which permits distances up to 100 meters. So I'll connect R2 to R1 with a crossover cable. R1 and R3 are 3 kilometers apart, so clearly we'll have to use a fiber optic connection here. Although Packet Tracer doesn't differentiate
Yeah, this is it.
between single mode and multi-mode, which is appropriate here? Well, multi-mode fiber allows distances up to 550 meters, which is more than UTP, but not enough for this connection.
Yeah.
Single mode allows much longer distances, 30 kilometers, 40 kilometers, even more. So in this case, we would use
But
single
where
mode
do I
fiber.
plug it in at?
Let's
Do I
connect them.
plug it in at Gigabyte?
Note that this symbol here is used for fiber optic connections in Packet Tracer. Notice the
didn't know
2
that.
spaces for both the transmit and receive cables. Finally, R3 and R4 are separated by 250 meters. That's too long for a UTP cable, but also not so long that we need single mode fiber. A multi-mode fiber cable would be sufficient. Let's connect them together. Okay, the devices are now all connected. That's all for this lab. Thank you for watching. That's all for this video.
So that was really good. I can honestly say that I understand cabling a lot better now. Highly recommend that you subscribe to this guy. He's really, really good. We are going to do a few more flashcards, and then we're gonna call it. And then day 3 of CCNA will happen on Monday morning at 7:30. We might go longer than what we're going right now, though. Don't know. All right, here we go. Cables are vulnerable to EMI, electromagnetic interference. That would be Ethernet cables, which is UTP, unprotected. Okay, because they're unprotected. Okay. Next, what is the speed of an Ethernet connection? 10 megabytes. Because remember, we saw that chart where it was Ethernet, fast Ethernet, things like that. Okay. 10 megabytes. Yep. IEEE standard blank is 10 megabytes. This is 802.3i. Yes. Okay. IEEE standard equals 100 megabytes Ethernet. That's, man, I get this one confused with this one in the 1,000. I think it's B. Now it's U. In a fast Ethernet connection, a PC receives data on which pins? It's going to be 3 and 6. Yes. Because everything's 3 and 6 except for the switch. Okay. Fiber optic cables are connected to blank transceivers and routers or switch. Fiber optic cables are connected to the small form factor pluggable. Yeah, small form factor SFP. Okay, we'll go all the way into where we'll go to 30. Okay, IEEE standards, 10 gigabyte Ethernet is 802.3 AB AN. Dang. Those are hard. Okay, in the fast Ethernet connection, a firewall receives data on which pairs? The firewall is it's still going to be 3 and 6. Okay. How many pairs of wires are in the 10 base T? 4. Yeah, we're good with that. Oh shoot, I didn't read that. Cables emit a faint signal outside the cable. Okay, yeah, we're good. Ethernet was originally defined as IEEE 803. 802.3. Whoops, I didn't read that one. I was too busy looking down here. Okay, 10 gigabyte maximum length is 10 kilometers. LR is how we know that it's fiber, by the way. In a fast Ethernet connection, a router receives data on which pins? 3 and 6, but a fast Ethernet connection, it shouldn't matter. I think 3 and 6 is like the standard now. What are the two main kinds of fiber optic cables? Single mode and multi-mode. Oh, wow. We're going through these. Okay. Well, we'll go through a few more of those. Okay. What is the speed of a 10 gigabyte Ethernet connection? 10 gigabytes. How many pairs of wires are used in a 10? Oh, all 8. Okay. Which is cheaper, single mode or multi-mode? Multi-mode. If IDX is disabled, what kind of UTP cable should be used to connect two routers? Crossover. Man, okay, I'm so glad that I know that now, because I've always struggled with that. IEEE standard blank is 1 gigabyte speed. I think it's UB. AB. I meant to say AB. I meant to say AB. Okay. Why are the wires in a UTP cable twisted together? To protect from interference. EMI. What is the speed of fast Ethernet connection? I think it's 10 gigabytes. 100 megabytes. 10 gigabytes, that'd be crazy. A blank connection allows both devices to send and receive data at the same time. Multi-mode duplex? Full duplex. Okay. Which allows longer cables, cable signal mode, or multi-mode? Oh, single mode is longer cables. Okay. Yep. How many bits are in 1 megabit? Isn't that 1,000? No, it's a million. Oh, because million. I could probably make the connection with that. Multi-mode fiber cables have a blank fiberglass core. Then is this wanting the diameter? Wider. Oh, no, it just wants wider. Okay. How many bits are in a terabit? Trillion? 1,000, million, billion, trillion. Hey, it's like Elon Musk. Elon Musk's a trillionaire now. Look at that. It's crazy. How many bits are in a kilobit? Now that is 1,000. Yeah. So, because kilo means 3, I believe. Or not 3, means 1,000. I think that's why people say 1K, 2K when they're talking about money. But I don't know that for sure. How many pairs of wires are used in a 1,000 base T cable? 1,000 base, I think it's all 8, right? Yep. Okay, we'll do one more. How many pairs of wires are used in a 1,000? Oh, a 1,000 base? It's going to be all 8. 4? Ah, I said 1,000. I read it wrong. It's got to read the question. Okay. So That's where we're at. We're gonna call it right there. Yeah. Yeah, we're gonna call it right there. I don't have my OBS set up to make myself like full screen. But I hope you guys learned something. If you haven't already, please go and subscribe to my my tech channel, which is just Tyler Lemmond. Okay. Kind of exposing myself here. Okay, go check out my tech channel, Tyler Lemmond. I'm all about doing stuff with like technology, tech things. I try to go over these labs. I try to explain things the best I possibly can, the most simplistic way I possibly can. If you're into the gaming stuff, you can go to check out Paradiddle Pete. But I'm trying to move all my tech stuff to there, so that way there's no like cross contamination between the two, stuff like that. If you're interested in the gaming stuff, on Tuesday we are gonna play some more Gears of War, but Monday morning at 7:30 we will do another study session. We'll keep going on with all these days of Jeremy until I can take and pass my CCNA. And then we will move on to the next thing. If you're someone who's here because you have liked my videos that I've been doing with the Network Plus Lab series, those are going to keep coming out. I just haven't had time to do them. But I do plan to work through all of those, just like I plan to work through all of the packet tracers as well. So go ahead, please like, subscribe, do all that good stuff. And I will catch you in the next one on Monday at 7:30. And remember, work with what you got and build what you need. I'm Tyler Lemmond. See you later.